Hello everyone, welcome back to Shenzhen IO. Okay, so let's get back to it. I noticed that I think the air quality on this screen here is always poor. I think the other factors change, but the air quality is the one thing that doesn't change. So, some things never change in Shenzhen. Okay, so let's get back to our concept mail. And yeah, so when I last left off, I was looking at this email. I did make a mistake in understanding David's email, so I just kind of glanced through his email as I was recording last time, and based on the title here, Virtual Reality Buzzer, I thought that because he said that he had met this wonderful girl and I guess they were doing some kind of long distance relationship, and I had assumed that he was talking about making some kind of sexual vibrator so that they could, kind of like a well, anyway, you use your imagination. I guess I must have a really perverted mind because that was just the first thing that came to my mind. But then later I reread his email, and no, it's actually, it's a little more innocent than that. So basically, they're moving in together, but David does a lot of VR. I guess he has, whatever the near future equivalent of the Oculus Rift is in his apartment. Remember, this game takes place in the near future. This is not quite present day. This is a few years into the future. So this is a slightly near future scenario. So I don't know exactly what kind of VR technology they have then. But anyway, the point is that he gets startled when people sneak up on him or enter the room while he's doing VR. And so he wants us to make a buzzer that attaches to his VR headset so that his girlfriend can buzz him and let him know when she needs him. So that's certainly less sexual than what I somehow in my mind assumed this was about. Still seems to kind of point to problems in the relationship when David gets so lost in his VR sessions that his girlfriend needs to let him know. It's kind of like those couples who can only communicate over instant messenger. They can't communicate face to face because of whatever. But anyway, that's none of my business. So yeah, so that's the deal here. I have to say, these little tidbits here, these emails here where, there's no goal, there's no puzzle attached to it, it's just kind of flavor text. It really is important to me. I was thinking about it and I thought, a lot of games don't have much of a story. In many games, the story is just totally a throwaway thing just used to justify the game. And in many cases, a lot of games would have actually been better without a story. But this, I think, is not one of them. I really do feel like this game is a better game for the story. It really gives kind of a framing, sort of a feel of the environment to this whole thing. Because again, this game is about being an expat engineer in a foreign country that it's the whole experience of being an expat. And David has really jumped right into it. You can see how David likes to use Chinese characters for himself and for his girlfriend. David is one of those I don't necessarily mean to make this sound pejorative, but he's one of those people. He's one of those foreigners who really takes to his new host country and tries to fit in by being a little excessive. This seems to be kind of a phenomenon unique to Americans. It seems to be especially an American phenomenon that when Americans go to some foreign country, they really want to they really want to be, for example, in China, they really want to be Chinese, and that's why David's trying to sort of show, hey guys, I'm really Chinese. There's actually, I think later on in the game, there's actually an email where he says something else about some ancient Chinese traditions, and somebody replies and says David is more Chinese than even the Chinese people. So that's kind of a common thing when when people go to a foreign country. It's if they choose to immigrate to a foreign country, that has meaning to them, whereas people who are just born in that country, to them it's just like, well, yeah, we were born here, so who cares? Anyway, sorry, I got off on a bit of a tangent there, but anyway, let's go ahead and do this puzzle and see what this is about. So, yeah, let's go ahead and start the design. Right, so the board is quite small and simple. We have here a transmitter. Oh yeah, this thing up here, you can click on, I don't know, it's not working now, but usually when you have this little symbol here, you can click on it to, oh, there we go. You have to click on it in a specific place. You can't just click on it here. You have to click on it here. There we go. So yeah, it's just to flip the part around if you'd prefer to have the pins on this side or on this side. That's all it is. So what do we have here? This is another puzzle based on X-Bus. And I have to say, I get a little annoyed by the whole XBus thing in this game. They really get carried away with XBus later on because, not that it doesn't make sense. I mean, digital data transfer is a very important thing in devices like this, but the XBus protocol is just a bit weird because of how it works, of how it blocks if it doesn't get any, if it's trying to listen and doesn't get any response, how it just freezes time and just makes the entire universe just pause while it's waiting for the XBus response. That just seems a bit bizarre to me. But anyway, so what do we have here? So this is now, so now we're actually getting into programming packets. So radio RX is, okay, I guess we just use RX. So this radio transmitter has an RX and a TX, a receive and a transmit pin, but I think we don't use the TX. We don't send data to it, we just receive information from it. So we're not going to send anything. We're not going to use this pin here. We are just going to use this pin here to receive data from the radio antenna into the VR headset. So what do we have here? So basically, when we get a data packet, read it and execute the corresponding command in the following table. So is that it? So basically, if the command is 0, turn off the buzzer. If the command is 1, turn on the buzzer. And here's the output that goes to the buzzer. That is really simple. This is a really simple introduction to XBus, I guess. I guess for people who are not yet comfortable using XBus, this is a good way to introduce them to what it's about and how it works. It seems like this is super simple, but let's see, maybe it's deceptively complicated in practice. So what do we have here? So we need to, right, so when XBus isn't sending anything, it just sends -999. That reminds me, one thing that I found out the other day, I was reading a little bit about this game. I didn't want to spoil any of the puzzles for myself. I did this puzzle a couple of years ago, but I've forgotten the puzzle solutions to all the puzzles I did, so I wanted to go into these blind so that I could, so that you could see my whole reasoning process in these puzzles, because I think that's probably the only reason why anyone would watch a Let's Play like this. But yeah, one thing I did find out is that there's this important command, SLX. Now, if I didn't know about this command, what I would do at this point is say something like, test if x0 equals -999. And then say, basically check if this radio input here is -999, and then if so, then just loop and just keep waiting until something comes in. If it's not 999, then act on the input. But here's the deal. I did find out that there is this command SLX, which means sleep while waiting for an XBus input. So what you can do here is, if you say SLX X0, this means that the chip just waits. It just keeps passing time until an XBus input comes in on pin X0. So that's a super important command because, like I said, otherwise XBus will just freeze time and just nothing will happen until you get that packet in. So yeah, if we do this now, why does it say part not sleeping? I don't understand why it says that. It should be waiting for, oh, I get it. No, sorry, I'm wrong. I can't use SLX here because it really is sending something. SLX is for something different. SLX is for when you actually get nothing on the XBus pin. Then you can say SLX, meaning wait for an XBus input. But in this case, we're not getting nothing. We literally are getting -999. Okay, so actually we do need to do what I was saying before. Test if x0 equals -999. And then if it does equal 999, then, come on, then I guess we'll just say jump to Ender, and then down here I'll have a label called Ender, and just say sleep one here. Come on. This automatic text formatting is getting on my nerves. I kind of thought it would. I dislike it. I dislike it very much when any text editor tries to automatically format what I type, because I end up just fighting with it because I know what I want to do and it usually doesn't. But anyway. Okay, so so here we say test if the input is -999. If so, go to the end. Otherwise, at this point here in the code, we can assume that we got an actual XBus input. So, how how do we say start that buzzing, start the oscillation if the input is 1? I guess what we can do is say move x0 into the accumulator first of all so we can work with it. And then, or actually, I wonder, can I just say test if x0 equals 1? And then if so, do not, so that it flips the accumulator around. And otherwise just move 0 to P1. Is it really that simple? This seems like it would actually do most of what we need to do, because what this is basically doing now is it's saying, test if the input is 1. If so, then flip the accumulator. If it's not 1, then obviously it has to be 0, because there are only two possibilities here. Either it's 1 or it's 0. So if it's 0, then just move 0 to P1 to turn off the buzzer. Boom, done. Let's see. Okay, it's not going to work because I'm not actually moving the accumulator to P1, but let me just see if does this do what I expect it to do? Hold on. What happened? What went wrong there? Something clearly went wrong. So test if x0. Oh, I see. Hold on. I think I see what happened. Let me check that again. Did that actually? Yeah. You can only get the input once. You read the input once, and then you don't have a chance to read it a second time. These are really just like one-time inputs. That's also annoying. That really kind of annoys me about how this whole XBus thing works. It's like you have to, yeah, that's, again, one of these things where the game just does something kind of funny and you have to work with it. Okay, so what we need to do then is not just say TEQ, we need to say move x0 into the accumulator. And that would block that would actually freeze time if we had nothing on x0, but it looks like there's always going to be, I'm assuming there's always going to be something on x0. It looks like it just keeps sending -999 if there's no other data, so hopefully we can count on always getting -999 from the XBus input. So I need to modify this slightly and say compare the accumulator and see if accumulator is -999, and I keep mixing up real-life assembler with the assembler in the game. In real life it's CMP for compare, in the game it's TEQ, test if equal. And if so, then jump enter, otherwise test if the accumulator equals 1. Oh, but you know what, I need to, okay, change of plans. Let's use the data, because I'm going to, obviously I used the not command to invert the accumulator, and this would mess with that if I was using the accumulator to check x0. So yeah, let's not use the accumulator to store this input. Let's use the data register. That's why it's there. That's why we have two registers. Okay. So is this going to work now? No, it does not. Okay, what's wrong here? What are we doing wrong? So 1 is in the data register here. So test if it equals -999. It does not. Test if data equals 1. It does. So we say not. Oh, you know what I forgot to do? I still forgot to move the accumulator to P1. Okay, now maybe it works. Oh, that, okay. Well, it's doing something, but it's not doing what it's not oscillating like it's supposed to. It's going high and low like it's supposed to, but it is not oscillating. Why is it not oscillating? Let's see. What are we doing wrong here? So, blah, blah, blah. Test it equals 1. Okay, do a not. Okay, that's fine. Move accumulator to P1. Yeah. Okay, good. Now it should go low. So, oh, I see. That's the problem. We're getting -999 here because it should just keep oscillating. Okay. Okay, so we need a way to make that oscillation continue even when we're not getting a 1 on the input, because we only get a 1 one time. And then after that, the oscillation has to continue. I mean, I need... Okay, so then... See, the problem is now I need 3 registers. I'm using the accumulator to generate the output. I'm using the data register to store and check the input. But the data register is going to get destroyed. If I read the input from x0 into the data register again, the current contents of data register are going to get destroyed. And then I have no way of checking the whether I should still be oscillating. I would need a third register to say, should we be oscillating now, yes or no? I really don't know how I should be doing this now, because this is the thing. We've got a state machine here, and the machine has a couple of different states. I mean, it basically just has 2 states. It's either oscillating or not oscillating. But I need to store that state somewhere. I need to have a register somewhere where I can store that information. Hey, you should be oscillating right now. And I can either use the accumulator for that or the data. Or I can use another chip. I mean, it really didn't seem like the kind of thing where I would need to use 2 chips. I probably don't need to use 2 chips. I probably just can't figure out. There's got to be a way to do with just 1 chip without bringing a second chip into it. But I mean, what I can do certainly is bring in a second chip here, like this, and say. Gosh, how are we? Okay, let's do it like that. Sure, why not? Okay. Right. Then I need to... Yeah, okay. I think this will work. I'll output the current state to this, and then this chip will actually do the oscillation. Man, this is really a hack. This is really like a really hacky way of doing things, but it works. Okay, or I hope it'll work. Okay, so what do we want to do here? So we don't need to do this not command here. We'll put the not command over here to invert the accumulator. And then move accumulator to P1, move accumulator to P1. So those commands will be run from this chip down here. So we can delete those from this code here. And move 0 P1 if the output, if we shouldn't be oscillating. So, okay, so. Okay, so we can actually just yeah, okay. Okay. And we can say move dat to pin, what pin is this? X2. Move that to pin X2. There we go. So that's the state. So our data pin will store the state. It's 1 if we should be oscillating, 0 if we should not be oscillating, and then this chip here contains the accumulator that will actually do the oscillation. Okay. So what we need to do here then is say test if x0 equals 1. If it does equal 1, then do the not and move the accumulator to P1. Otherwise, move 0 to P1 and sleep 1. Okay, how does this look? Why is it... Oh, I see. That's interesting. Yeah, because I'm not actually moving any data. It's freezing because I'm not moving anything from this chip to this chip if the input's minus 999. So actually, can I do comments in this game? No, comments do not seem to work. Maybe like that. Oh yeah, you can comment out a line with a number sign. Okay, cool. So then actually, hold on. Okay, what I'm doing now just seems stupid. Yeah, so I don't even know what I'm doing anymore here. So, right. So if it's like that, right. So that looks fine. Okay, I see. And so this gets... Oh, I see. The problem is... Oh, I see. The problem here is that... Right, okay. So I need... Darn, I mean, basically I need this chip to just... oscillate when it gets a 1. Okay. All right, let's see then. What are we doing here? I have no idea what's going on anymore. I really feel like I'm doing a pretty stupid solution here, but let's see how this works. So let's see. So let's say check if accumulator equals minus 999. If so, then right, then just move dat to x2. Otherwise, move the accumulator to dat. So basically what this is doing is now, if we get no input, if we just get a minus 999, then just give the current data value to this chip here and be done with it. Otherwise, we move the accumulator into the data register here. So does that work? Yeah, whoa, okay, well, that almost works. Okay, wait, why is it delaying here? Okay, we're close now, but it's delaying by 1 cycle sometimes. So the question is, why is it? Oh, it's doing that if, oh, I see. Okay, quick correction here then. We always move the accumulator to P1. So, because the problem is the accumulator is being left high, it's being left at 100 when it shouldn't be. So we always move the accumulator to P1 unconditionally. And instead of saying move 0 to P1, we say move 0 into the accumulator if the output is, if the state is 0. Okay, does that work? That looks like it's working now. That looks like it is working. Did I really need 2 chips for that? I really feel like I should have been able to do that with less. But yeah, I mean, clearly that was not the most efficient solution. But it works. David is pleased. This is exactly as he had imagined it. Okay, well, that was that. I'm not good at making things efficient. I'm sometimes good at making things work, but I'm not good at making them pretty or beautiful or elegant or efficient. That's not my strength. Okay, so here we come to prototyping. So this is kind of cool. This is actually the game's sandbox. So what happens here is this is not really a puzzle. What happens here is the game gives you some stuff like custom LCD panels, and you also get LEDs. They don't mention that here, but basically, let's go ahead and take a look. Let's see what they have for us. So yeah, so here in the parts bin now we have, I mean, these are the usual parts that we always get. This is the stuff that we've seen before. These chips here are RAM and ROM chips, which we haven't used yet and probably won't use now, but yeah, and then these are the logic gates I talked about. There's a NOT gate, an AND gate, an OR gate, and an XOR gate. And this, what is this? I don't even know what that is. But then you get other parts which you don't normally get in the puzzles. Like this is a push button. Oh, I guess I have to stimulate. Now we can push it. See, it's just a push button. And you might have noticed that the music stopped. The reason for that is because we have parts here that can make sounds now. And so out of respect for the sounds that we can generate here, it turns off the background music when we run our devices here in the sandbox. So yeah, in terms of sound generating devices, we have two devices here. This is just a regular piezo speaker. I guess the BZ here stands for buzzer. It's like a buzzer. So it has 4 simple inputs. That's it. It just has 4 inputs. And the way that this button works is, I think it just generates 100 if you push it. So there you go. It sounds the buzzer. And you can experiment a bit with different tones by, if we get, just get a chip here with a simple I/O pin on it, and say move, I don't know, let's say move 50 to P1, and then sleep 1. Let's see how this sounds. So you get a tone. And the higher your simple input or output value is, the higher the tone is. And I think this button, this push button just always generates 100. So I think the sound the button makes is equal to if you said move 100 to the thing. So if we do this, yeah. And if we comment these out for a second, yeah, we get the same sound. So yeah, the button just generates 100. It's like a simple 100. And here's a switch. This is the same idea, except this is a toggle switch. So instead of a momentary push button switch, it's a rocker toggle switch. Nice. There's stuff like this. We've seen this before. You can, I think you can you not? Oh yeah, you can change the value in circuit while the circuit is running. So this is just an XBus number. It's just like a thing that generates an XBus number. This thing is, oh yeah, I think this is like a game controller because it has WASD keys on it and then IJKL. They used to have an actual game controller here, which was more like a game controller. It had WASD, but it also had space. But they replaced that with this, which is kind of a pity because this does not have a space input on it. It has obviously, you know, these 4 keys, and it does, you know, like it does exactly this. If you press while the circuit is running, if I press W now. Well, you can't see it. There's no visual indication of it. But if I press W and hook up the output here to a chip, that will generate a number 1 on the XBus outputs. So, excuse me. So this is a way to add interactivity to the circuit. And some people use that for making games. Some people have actually taken like this display screen here. And this is if you want to add a custom screen to the screen. But if you click on that here, you get this matrix. And it's just it's a 10 by 11, I think. Looks like it. Yeah, 10 by, or is it 12? Sorry, 12. Yeah, that's right. It's a 10 by 12, just graphical LCD kind of thing. So you can, and you can, let's see, what do the pins do? I believe, what were they? T is, I believe, for touch screen. This display also has a touch screen function, so you can actually like touch the screen and it will generate If you look at what it generates on the X bus pins, I think it actually generates like, let's see, if I run this into an X bus here, are we actually going to see? No? Wait, what? Generating 45. I don't know why it's generating a 45. I thought that... Okay, I don't know. Maybe it's because I clicked here. I don't know. But anyway, it works something like that. And then Q, I think, is if you want to query whether a segment is on. And then C is if you just want to change the segment. So, for example, you can say... I think the syntax is just... I think it's literally just the number of the segments. So like if we wanted to turn on, let's say we want to turn on segments 1, 3, 5, and 7. So let's say move 1 to pin X1 so that it goes from here into the C input. So move 1, move 3 to X1, move 5 to X1, and then move 7 to X1. And it's just for good measure, let's move 8 to X1. So we should see 4 blocks with a space between them, and then here 2 blocks at the end. And then I guess, do I have to do sleep 1? I don't know, let's do sleep 1. So now, yeah, see, exactly. So that's how you do it. That's how you control the screen. And it's not much. I mean, it's obviously not high resolution graphics, but it's enough for some stuff. Probably the most obvious application of this is Tetris, and I've seen, if you look on YouTube, you can see many people who have made Tetris games using this screen and then, you know, the input controller like that. So Tetris is something you can do. Some people get a little bit more imaginative and build, you know, more elaborate games, but, you know, it's a screen. It's a graphical screen. You can put it's a 10 by 12 graphical screen, so you don't get super high fidelity, but you can do stuff with it. And these 4 things are just colored LEDs. So, for example, this is a red LED. Again, these are all simple inputs. So if I say move, I don't know, let's see, if I move 20 to P1, and you look at it, you can see it faintly glows red. But if I go all the way to 100, now it glows red more brightly. So yeah, so that's, you know, red LED, green, I guess amber, A for amber, and then W for white, obviously. And then this here, I think we've seen this thing already. This is a text LCD. So the other one was a graphical LCD. This one is a text LCD. So if we say move, how does this work? 1, 2, 3 to X1. Does that work? Yes, it does. It literally just shows the text that you send to it through the X bus pin. That's it. It's that simple. It's pretty effective, pretty simple, but it works. So yeah, this is only text, and you know, this is graphical, and then there's the buzzer that we saw. And this thing is pretty cool. This is the FM Blaster, which is an obvious reference to the Sound Blaster, which was, you know, a popular one of the first popular sound cards for PCs back in the day. Let's see, if we flip this around, yeah, there we go. So the FM Blaster is pretty cool. It has 2 X bus inputs. I think the first version of this game only had the buzzer, and somebody made, you know, some people were making videos of them playing music on the buzzer, and so the designers thought, okay, let's give people a little bit more creativity and give them a thing with like actual synthesized instruments. So this FM Blaster in this version has 2 pins. The pin here with the guitar on it, as you might guess, chooses the instrument. So there are 10 instruments programmed into it. So you can just say something like move 5 into X1. That will choose instrument number 5. I don't remember what the instruments are, but I guess we can find out. So that's that, and then the other X bus input controls the actual note. So, and there's a listing in the manual of what each note corresponds to. Let me see, what's... I don't know, let's just say... I don't know, if I remember right, it was 45 middle C? I don't remember now, but let's try that and see if that works. So let's try that. Yeah, there we go. So it just keeps playing middle C with that instrument over and over. And it doesn't sound very good. Let's try a different instrument. Let's go through the instruments in order. I think the instruments are 0 through 9. It doesn't sound very impressive if you just play one note over and over. Yeah. Now it just sounds kind of like sonic junk. But, okay, that's a little bit more of a pleasant sound. Okay. If you actually started making notes with this might be an interesting sound. Now it just sounds weird, but, yeah, I'm not making it sound very good because I'm just playing one note over and over, but if I say like sleep 5, does that make it sound different? There we go. Now it almost sounds like something you could make music from. So let's say, if I say move, I don't know, 50, sleep another 5, and then move 55, sleep another 5. What does this sound like? Yeah. That's almost like the beginning of a basic arpeggio. It's almost like the beginning of something. So you can see you can make music with this. At first it sounds horrible, but once you start figuring out how to introduce timing and delays and things and play different notes, it's actually not that bad. You can make some pretty cool sounds with it. Let's see. Okay. Instrument 6. It's like a vibraphone or something. What does 7 sound like? Okay. Also kind of weird. Most of these instruments sound kind of weird, but I think this is supposed to be a percussion. Yeah, I think at the end they have 2 percussive instruments. Yeah. Just a drum. So yeah, it doesn't seem like much, but as you can imagine, people have done some fairly impressive things with it. Probably the most impressive one that I've seen is a rendition of Rasputin. So there was a disco song from the 1970s called Rasputin, and somebody actually rendered it using a whole bunch of these FM blasters and a huge array of microprocessors or microcontrollers in this game. If you look it up on YouTube, you should be able to find it. Just do a YouTube search for Shenzhen I/O Rasputin, and you should find it. It sounds pretty cool. I mean, it's obviously an acquired taste. Some people don't like the sound of these FM instruments, but I think it sounds great. And you know, they have like 20 of these FM blasters. They're producing different sounds at different times. So, you know, if you really want to get creative and really do some cool stuff with this, you can. But at some point in time, you kind of have to ask yourself, why do all this inside a game? Why am I doing this using these limited tools in a game when, if this is something that's really interesting to me, I could get a real sound synthesizer for not much money? I mean, let's face it, a chip that does sound synthesis doesn't cost that much money. You could probably do more with it and get more flexible reactions out of it. So, you know, it's a matter of perspective. It's like, do you want to do all your stuff in a game, or do you want to start making it real and doing it for real? On that note, I think this is probably a pretty good place to stop. So I didn't really plan to play this game all the way to the end. And looking ahead, I mean, if you start looking at, oh yeah, this was funny. Wait a second, I thought China was communist. Why is everyone shopping at the store? What is up with that? It's like Jerry Seinfeld suddenly started writing commentary on this. Communist China. People are so surprised when they get here. They had no idea that things were changing. So, yeah, it's kind of like that. I mean, you know, people talk about the end of communism, but no, there was no end to communism. Communism ended in Europe, but not necessarily in other parts of the world. So yeah, so there's that, and then this is the next puzzle. Game console. This was weird. This was also something involving XBuzz, if I remember right. This was, yeah, bunch of Xbox inputs. Yeah, they just start getting really crazy with all these Xbox signals, and this is some spam. We're getting virtual spam in our virtual world. And then this, this has something to do with laser tag. Is this also... Oh no, this is not XBus, this is just regular simple inputs, but anyway, yeah. Okay, so yeah, like I said, I think this is a pretty good place to stop. I mean, I really love this game, don't get me wrong, I do love this game, but you reach a certain point, and for me that point is right around here, where you start saying, I'm just a little frustrated with the constant limitations of the game, because in real life you could do so much more. There's the constant frustration of not having enough room for all the code that you want to write. And I know that's the challenge of the game. The challenge of the game is to find ways to do what you need to do in a smaller code space, using less code. That's the whole point. That is the challenge of the game. But it just seems so contrived to me because, you know, I mean, I have programmed microcontrollers and things like that in real life, and even the very first computers, like literally the very first microcomputers, had more memory than like 9 lines worth or 14 lines worth or whatever. I mean, in this game, your chips only have enough memory for I think 9 lines for the small chips and then 14 for the big chips, which is totally unrealistic. Even with like 1 kilobyte of RAM, which is, you know, nothing, or even like 256 bytes of RAM, you could have more than 9 CPU instructions, way more than 9. So just the way that they've done it here in this game, it's just really unrealistic. And then if you need more space, then you do what I did here. You start setting up, you have like multiple chips cascading several microprocessors into each other, where like you run out of room here and they just have this chip output its result to the next chip, and then the next chip just becomes another link in the chain. And you just have like, you have a device with like 5 microprocessors inside it that are all just chained together because there wasn't enough room to write code on one of them. And that's just silly. That's just kind of getting silly. So, you know, I like I said, I do love this game. Don't get me wrong. I don't mean to come down too hard on this game, but there are these ways that they try to make the game artificially harder. And in every puzzle, you know, the puzzles are not even that complicated. And for me, it's like, at this point, in every puzzle, I know what I'm supposed to do. It's just a question of, you know, how to do it, how to implement that within the very limited space that they give you here. And it becomes more frustrating than fun after a while. That's the thing. Later, I mean, I had so much trouble with this puzzle, and later puzzles get much, much harder than what we've seen so far. So, you know, we're not even getting started on real complexity in these puzzles. And yeah, I mean, it's just, you know, you reach a point where it's just not fun anymore. It's like, okay, the game gets off to a great start, and then you just reach a point where you say, really, like, are you really expecting me to do all this stuff with 9 lines of code or 14 or whatever? It's just, nah, man, it doesn't, it doesn't, no. So, yeah. Sorry, folks, but I think that this Let's Play wasn't very popular anyway. I noticed that a lot of people weren't watching these videos towards the end anyway, so I think, like I said, I think this is a good place to stop. Again, Zach of the eponymous Zach of Zachtronics, he commented in his talk at Google. He said, you know, they did a lot of user testing to see where people stop playing the game, and most people have a natural point where they just naturally stop playing. Some people play the game all the way to the end, but most people don't. Most people don't play this game all the way to the end. This game has about 30 puzzles in it total, like roughly. I don't know exactly how many it is, but there are roughly about 30 puzzles. So I've done 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, so 9 puzzles out of 30, so just under 1/3 of the puzzles. And like I said, the later ones get much harder. So, you know, there are quite a few puzzles here, and there's a lot of challenge here, and if you like that kind of thing, you can definitely challenge yourself with this. But most people just naturally at some point say, you know, I've had enough. This isn't fun anymore. I'm just going to stop here, and that's okay. That's the thing. It's okay to stop playing the game when you have fun. You don't have to play the game all the way to the end. You're not required to finish it. Don't see it as a job. It's not some task that you have to finish to get paid or something. I mean, in the game we're getting paid because we work for this company, but in real life it's a game. And when you're done, when you stop having fun, you reach a point where you naturally just want to stop playing, then stop playing. So that's what I'm going to do now. So I hope that this was fun to watch for those of you who did watch it. I hope that it was at least mildly interesting. I know I had fun with it. I mean, once again, I know I keep saying it, but just to be sure, I do love this game. It is a great game. It is, I think, by far the best game that Zachtronics have ever made. Not just like their other games, because their other games are good as well, but this game is really just like the pinnacle of their development. This is far better than their other games, in my opinion. That's just my opinion. But yeah, this has been Shenzhen IO. So thanks for watching, everyone. Hopefully next time I will come back with some more usual games that are more what people associate me personally with and what people expect to see on my channel, and we'll go from there. So again, thanks for watching, folks. Take care, everybody. Stay healthy out there, and I will talk to you later. Bye-bye for now.